ended the class with this, where we talked about how if I gave you the vertex and I gave you a point, in the example, it was a y-intercept. It doesn't have to be a y-intercept. You could come up with the equation. Do you remember that? Okay. In the book, they give you one that's like a word problem. And I don't want you freaking out about the word problem because it's not a big deal. I'm going to try to navigate to the book real quick. But basically it says your vertex is 120. Oh, you guys can't see online, can you? Your vertex is 120, and your y-intercept, which we said it doesn't have to be the y-intercept, is 4. Go ahead and on your own real quick, try while I'm pulling up the problem. I want you to give me the equation in vertex form. That's what we ended on yesterday. Yeah, f of x is the same thing. It doesn't matter. The book will probably write it as f of x. I'm writing it as y just so when you plug in, it makes it easy. So just to show you, this is the way the problem is worded. But if you look, this is all I care about. That's the way it's worded. Height of a thrown ball is a quadratic function of the time it has been in the air. Right? Look at this. It looks scary, right? But what all you have to do is go, the vertex of the point is 120. I'm going to highlight or underline that. The path of the ball includes the point 0,4. I'm going to underline that. What is the expression that defines this function? Write it in vertex form. So that's what I'm doing. I'm highlighting that. So basically, they told me the vertex, they told me the y-intercept, and I'm going to write it in vertex form. So first off, what does vertex form look like? And you're not going to have your notes, so you got to start kind of like, remember last night you didn't have homework, but you did have homework. What should you have done? Should have gone over this so that when you come into class today, you know y equals a x plus or minus h squared plus or minus k. And you know this is your h, this is your k. When you plug in the h, you always do the opposite of what you see here. So it should have been a x what? Minus 1 squared plus 20. So last night you didn't have homework that you had to write down necessarily and turn in, but you did have homework. You should have been looking at these notes. And that's what this class is going to take. Then, what other thing did I need to find? I need to find A. What's the problem? I don't have A. What's the problem? I have how many variables? No, I have 3. I have a y, an a, and an x. That's why this thing comes in handy. That's a x, and that's a y, which means I can take that y, put a 4 there, a, put a 0 in for x, and now how many variables do I have? 1. I don't know why it's doing that. So if I do 0 minus 1 is negative 1 squared is no 1. 1 times A is, and I kind of had to stop there because I can't add A to 20, right? So to get this by itself, and minus 20, and I get negative 16 equals A. Boom. Y equals negative 16 x minus 1 squared plus 20. Now I used my A and I plugged it into my equation. Does that make sense? All the question said was given that vertex and given that. Oh. Did we pass that black? That's picking up the sensor. Does that make sense? I mean, yeah, could they get harder? What if they can maybe not use as pretty numbers? It could be a fraction, like that's okay. The process is not getting harder. No. Now, the next part of the question says to take that and to write it in this form. Okay, the next part of the question says to write it in this form, which we haven't yet talked about, but that is called standard form. That's going to be the next form I'm going to talk to you about. Okay, so I'm gonna put a pin in this problem real quick, and let's just finish up vertex form. What is vertex form good for? Good for vertex. When I have the vertex, what else do I know? Daisy, what else? What other thing do I have? No, not from the vertex. I can find the y-intercept. How can I find the y-intercept? What? No. If I'm on the if I want the y-intercept, what do I know has to happen? X is 0, so I can plug a 0 in for x and solve for it. Yes? Yes or no? When I know my vertex, what other important key thing did we talk about that I know? Because it goes through it. The axis of symmetry. What's the axis of symmetry for this one? Nope. That's the y-intercept. Nope. Don't guess. There should be a reason and you know. So if I said I had a parabola and my vertex is -3, 10, I would tell you my axis of symmetry is x equals -3. If I had a parabola that had a vertex at 5, -4, I would tell you the axis of symmetry is x equals 5. It's not just a 5. So what would be my axis of symmetry for this problem up here? X equals 1. What is this, guys? That's the y-intercept. What is this? That's the vertex. That's where I'm going to get the axis of symmetry from. Yes? Vertex form. You should be able to give me a vertex. From vertex form, you should be able to give me an axis of symmetry. Those should be very quick and easy because vertex form gives me the vertex. Once I get the vertex, I got the axis of symmetry. How would I find the x-intercept? Plug in 0 for y. If I wanted to find the y-intercept, what would I do? Plug 0 in for x. Yes or no? If I wanted to find the concavity, concavity is just which way is the graph facing? Is it facing up or is it facing down? You would look at this number right here, and what would that tell you that that parabola is facing? It's a -16. As soon as it's a -16, what does that tell me this thing is facing? Down, yeah, it's a negative. Does that make sense on how I know that all that information? When you're in vertex form, that's the stuff you should think. I know how to get my vertex. I grab it right here. I know how to get my axis symmetry. I get it from this. I know how to find my x, my y-intercept. I know how to know which way this thing is facing. As soon as you see vertex form, all that stuff should flood to the front of your brain. Now what the next part says is it says, hey, I need you to go ahead and take this form and change the way it looks. And the way we want it to look is like this, which is called standard form. Well, remember when we did linear crap? How many forms did we have? What are they? Slope-intercept form. What's slope-intercept form good for? A slope. And an intercept. If I was doing that, I would grab the intercept, plot that point on there, use my slope, go to the next point, draw my line. Do you guys understand? I'm just talking like how you would attack slope-intercept form, yes or no? How would I attack point slope? That's standard, but yes, you're right. That for standard. So if I wanted standard, what's standard form good for? My x and my y intercept by plugging in 0 for them. Point slope is good for a point, just any random point, and a slope. And again, I plot the point they give me, then I use my slope, and then I draw my line. Right? You should know how to attack every one of those types of problems. You should know what they look like. You should know how they behave, all that kind of stuff. We're going to do that same thing for parabolas. The first way I'm going to tell you that they're going to give you an equation is possibly in vertex form. That's what we did first. We know how it behaves. I know how to get the vertex from it. I know how to get the axis symmetry. I know how to get the x and y intercept, all those important things. Yes? This next form is called standard form. And I'm going to teach you again the important things from standard form and how to find the vertex and all that from it, but not yet. Right now I'm going to show you how to change vertex form into standard form. From Algebra 1, if I gave you this problem and I asked you to change, remember all we do is change the way things look in math all day long. How could you change the way that looks? What could you do with it? What?
Foil.
Yeah, I don't like that word. I'll tell you why in just a minute. But yes, you could FOIL it, which means when you square something, you're timesing it by itself. Yes. And then like he said, you could FOIL it. I'll tell you why I don't like that. But x squared, this times this is a negative x, this times this, negative x, this times this, a positive 1. I combine a negative x, and what does it become? No, it does not. That's why we have a trouble in Algebra 2. It is not x squared. If I have negative 1x and I have another negative 1x, I have negative 2x. You have an x over here that's negative. You have an x over here that's negative. When you combine, you have 2 negative x's. Okay? We got to get that down. That's going to kill us if we can't get that. This right here and this right here are the same thing. So when I go to rewrite this, I can write this as negative 16. Instead of writing this, I can write that. Do you understand? Yes or no? Questions on that? Then what can I do with it? Because I got to make it look like this. It doesn't look like that yet. Distribute what? I can multiply that negative 16 times everything. Distribute it. Negative 16 what? What's next? A negative 16 times a negative 2x is a? And then times 2 is 32, and then just x. And a negative 16 times a positive 1 is a? combine like terms, and I finally get y equals negative 16x squared plus 32x. Oh, that should be plus 4. I have now changed vertex form into standard form. What would happen if I graph this and I graph this? When I graph this view, it would look like that. Or actually, that's false. It would be facing down. And when I graph this one, it would be the same exact graph. These two things are the same exact equation. They just look different. It's kind of similar to how a 5 is the same thing as 10 over 2. Those are the same exact number, they just look different. Same exact thing is happening here. Those equations are the same. I just did some math magic. Jazz hands. What? Yes, I will tell you why I don't like FOIL. Did everybody understand this so far? Questions before I move on? Here's why I don't like foiling. I understand why they teach it. You don't have to write this. Foiling only works with a 2x2. You can't FOIL this. You would do this times this, first times first, outside times outside, inside times inside, and last times last. Notice that 3x never got used. You know how I teach how to do this? First off, I don't think you need to memorize. You notice how when I said first, outside, last, like I had to remember what the F, the O, the I, and the L stood for? Do you get what I mean by that? Okay, but here's what you have to do, right? All you have to do is everything in this bubble has to multiply by everything in this bubble. That's it. I mean, don't make it any harder than that is. So this x squared has to multiply by how many things? 2, by the x and by the negative 2. This plus 3x has to multiply by how many things? 2, the x and the negative 2. This plus 3 has to multiply by how many things? 2, those two things. So if you were doing this, you would do x squared times x. By the way, this is stuff that we need to be able to do, and I found out my Algebra 2 kids can't do this. We keep getting all kinds of like 2x's and all that. No, you do the number in front. What's a 1 times a 1? So it's still 1, but when I do x squared times x, legit, you just add the exponents. Or think of it like this. What does x squared mean? Doesn't it mean x times x? Yeah. And what happens when I have x times x times x? What does that really turn into? X cubed, right? Or you can just add the exponents. Same basis. That's all stuff from like middle school. X to the third or Algebra 1. Then this times this is a negative 2x squared. I'm done with this one. A positive 3x times a positive x is a positive 3x squared. A positive 3x times a negative 2. Positive times a negative is negative. 3 times 2 is 6. And then there's no x to combine with it, so it's just x. I'm done with this one. A positive 3 times an x is a 3x. A positive 3 times a negative 2. Combine these guys. What does that become? A positive x squared. Combine these. What does that become? A negative 3x. Combine these. Nope, that's it. There's your answer. So I don't teach FOIL. Make sense? So what's the difference between this and this? And this is why, and I'm glad you asked. What's the difference between this and what's the difference between this? Here, I was adding or subtracting them. Here, I'm multiplying them. Totally different rules. Adding and subtracting have different rules than multiplying and dividing, always. Even this year, we're going to do things with like adding and subtracting, and then we're going to do it one multiplying and dividing. They have different rules, and you got to know their rules. When you add them, you're just counting how many you have. I have -2x². I'm adding 3x². What happens every time I have a negative and a positive version of the same thing? They cancel each other out. Right. So what would it be? No. You have 2x² here. You're adding 3x². You have, because you're just saying I have 5 of these same things. The only reason we can combine them is because they're the same things. So you're saying I have this many total. I can't add the x³ and the x² because you go to put them together and they don't go together. I combine the x² and the x² because they match up. They're the same terms. They're like terms. When you multiply, it doesn't matter, right? I don't even think about that. When I multiply, if I do 5x times 5y, can I multiply those? Oh yeah. That turns into 25xy. But if I went to go 5x plus 5y, can I combine those? No. Why? Different things. When I multiply, different rules than when I add. In order to add, they have to be the same term, and they're not there. So these are the things we got to focus. So every time I add and subtract to do that, if you have a question, make sure you ask, because those are going to be the things that kill us. Okay? So have no problem answering that. That's the thing that I think, that's the part that I'm saying about Algebra 2 is tough. You don't know every single rule and you mix them all up, you're in trouble. But it's okay. We can fix it with effort. Right? We can fix it with effort. We can't fix it though if you're just kind of just sit there. So ask away anytime. All right, so let's talk about standard form. Standard form, what's it good for? Not absolutely nothing. No, you guys don't like my joke? Okay, forget it. It looks like this. That is going to be standard form. Standard form, guess what it's not good for? It's not good for my vertex. As far as I mean, it's not good for my vertex. Remember how vertex form, you literally didn't do any math, you just grabbed the numbers? Standard form, you're going to have to do math. It's going to take work to find it. It's not hard work, but it's just not like it was in vertex form. I love vertex form to find the vertex because I don't have to do anything. I just look at it and I can grab it. Okay? But standard form does have something that you can just grab. It gives you the y-intercept right away. The y-intercept is sitting right there every single time. Now, why does it make sense that that's the y-intercept? What does x equal if you're on the y-intercept? What's I don't care what a is, what's 0 squared? 0, and what's 0 times any number? So if I put a 0 in, that's going to cancel out, right? If I put a 0, what's 0 times, I don't care what number b is, if it's 0, what's 0 times anything? So what's going to happen to both of these? When I put 0 in, they're both going to cancel out, leaving me with just the c. Right, so that's why standard form, the y-intercept is just sitting right there for you. So there is a way to find the vertex. Remember, the vertex is the most important point when I graph. So the way I'm going to do this is I'm going to say the vertex is the opposite of b over 2a. Now, that is only the x coordinate to the vertex. What's the problem? What's our vertex consist of? It consists of a x and a y, correct? Well, when I find the x coordinate, what did I tell you? Anytime that you find the x, what can you do? So you would then plug it in, and then you would do the math, and after you plug in, you would find the y. You need to know this. Opposite of b over. Right? So you're going to do now, a is called the coefficient of the x squared, b is the coefficient of the x, and c is just the constant that's sitting back there by itself. So let's see. If I asked you to find the vertex, what would you do? No. I know the y-intercept is 4. Yes, you're correct, but I'm asking for the vertex. You wouldn't tell me anything about the y-intercept. Okay, so let's first label A. What is A? No. 1. It's the coefficient in front of it. When there's nothing here, there is something there. It's a 1. What's B? 2. What is C? Does everybody understand how I found those? Now when I do opposite of B, does everyone understand why I put -2 over 2A, which is 2 times 1, which tells me a -2 over 2, which is a -1. My x-coordinate is a -1. How do I find my y or my y for that? Y equals -1 squared plus 2 times a -1 plus 4. And I on purpose did something wrong. We talked about it at the beginning of the year, but I need to make sure we keep remembering it. This is not read as -1 squared. You must put those parentheses, because if I put this in a calculator, what is the calculator going to spit out? Yeah, but what's the wrong answer? No, the calculator will spit out the right answer. It will say -1. Because what the calculator is doing is what it's doing correctly is it's saying this is like -1 times 1 squared. And it does the 1 squared first, then applies the negative. You don't want that. You want -1 squared, so you have to put it in the calculator like that. And then that tells the calculator, I want -1 times -1, which is a +1. These little subtle things are the things that screw us up. They make a big difference. So then I go, okay, this is +1. This is a -2, and that's just a +4. This and this is -1. -1 plus 4 is 3. So my vertex would be -1, 3. And we're getting ready to leave. What does that mean my axis of symmetry is? If you say -1, you're wrong, and I keep telling you this, you're going to get it wrong. X equals -1. You must put the x equals in front of it. You can't just put -1. It's not a number, it's a line. X equals -1. Yes or no? If I want, what's the y-intercept? 0, 4, and it's just sitting right here, right? What's the x-intercept? What would I have to do? I'd have to plug in 0 for y, and it would get this. And you would have to use what we call factoring to solve that, which I don't know if we know that very well. I'm going to teach factoring. That's what we're going to talk about tomorrow. We have to solve this by factoring. No. Does that make sense so far? Questions on that? All right. Oh, yeah. What if I asked you to graph this? What if I said, hey, I want you to graph this? What's the most important thing for you to find? Okay, so you'd find the vertex first. Does everybody understand we just found the vertex? Vertex is -1, 3, yes? Then what could I do? What would be numbers I could plug in? I remember I go to the right. So what would be to the right of -1? 0. I would plug that in for x. And I get an output, yes? Which would be 4. By the way, since I plugged in 0, don't I know that that's already right there? Didn't I know that 0, 4 was supposed to be the y-intercept? What would be the next number I plug in personally? 1. And literally you plug in 1. So it would look like this. 1 squared plus 2 times 1 plus 4. All I did is I changed all the x's to 1s. 1 squared is 1 plus 2 plus 4. 1 plus 2 is 3 plus 4 is 7. Yes? I would then plot these points. I'm not plotting them correctly. I plot the vertex, I plot that next one, and then I plot the next one. So I plot this point, then this point, then this point. Yes? That would be only the right side of the problem. What would I do to get the left side? Mirror it, and boom, I've got this graphed. You should be able to plot something in vertex form and something in standard form right now. You should be able to graph it. So, try graphing this. Try graphing that. I got it. I gotta talk to him out. You're good, you're good.
Excuse me?
Yes.
For the negative b over 2a, is that x? Like, does it equal x?
That's the x coordinate of the vertex.
Okay, I'm just making
So remember the x, there's a x and there's a y. So when you do the opposite of b over 2a, that's only this piece of the vertex.
Yeah. Okay.
Yep.
Thank you.
So if I ask you to graph this. First off, opposite of b. My b is 4, right? Hello? So what's the opposite of b? So -4 over 2 times -2. A is -2 in this case. You with me? This is A, this is B, and this is C. So that's where I got my A and my B from. Then I get -4 over -4, which equals +1. So 1 is my x being 1 is my vertex, yes? Now I plug in -2 times 1 squared plus 4 times 1 minus 3. And I do order of operations, right? I got to do 1 squared is 1. 1 times the -2 is -2. 4 times 1 is a +4 minus 3. A -2 plus 4 is 2. 2 minus 3 is a -1. So 1, -1. Does that make sense? That's my vertex. By the way, where did you notice I concentrated with my graph? Third and fourth quadrant. Why? What way do I know this graph is facing? Down. So because I knew that because of my A being negative right there. What other point can I graph really easy because I already know it? What's the y-intercept? So, boom, boom. If I went back 1 and down 2, what can I do? Go to the right 1 and go down 2. Do you see I already have 3 points now? Are you with me, yes or no? What could I do to finish this off? Plug in a what? What'd you say? What is x equal than this one? Stop doing what you're doing and talk to me. What is x equal when I'm on this one? 1. What does x equal when I'm on this line? 2. So what would be my next point over that I'd plug in to find? 3. So I would plug, this is like making x and y chart. And I'd be plugging in 3 for this. My thing will let me. And that means I'm going to replace all the x's with the 3 and then do order of operations. So it's going to read 2 times 3 squared plus, ooh, that's a negative, plus 4 times 3 minus 3. That squared is 9. 9 times that is a -18. Plus 12 minus 3. This and this make a -6. A -6 and a -3 make a -9. So it would be 3, -9. So 3, 4, 5, 5, 6, 7, 8, 9. 3, -9. And then I went over 1, 2, and then down to this. So I'm going to go back to 1, 2, and down to this. And boom, there's my parabola. You should be proficient at graphing both of these, yes? All right, you'll have practice on that tonight. Remember, you'll see 2 homeworks. You only have to do one of them. The other classes got more